Hi students, in this video we are going to learn about binary relation on a set. You just observe this from a set, from one set, otherwise single set only we are going to create this relation. You just observe this, when I read the meaning you will understand what it is. Let A be a non-empty set. Then every subset of A cross A is called as relation on A. Normally here we have A cross B, but in this binary relation on single set means the first set itself is the second set. That's why it's called as binary relation on a single set. So let A be a non-empty set means then every subset of A cross A is called a relation on A. Now we will see some important information here. Since pi is the subset of A cross A, you know that empty set, void set is the subset of all the set. Hence pi is the subset of A cross A. So pi is also a relation on A called the empty or void relation on A. The second important point is we know that every set is the subset of itself. Hence A cross A is the subset of A cross A. So A cross A is a relation on set A. That relation is called universal relation on A. I hope you understand this. Next one is let identity element of set A. It is an identity, that is A and A both are same. The same A comes here also without losing its identity. Hence A cross A, where A belongs to set A, means clearly the identity relation is the subset of A cross A. Therefore it is a relation on A. It is called as identity relation on A. Now we will see some problems based on this concept. Let A is a set which contains the elements 1, 2, 3, and let R is a relation which contains the elements 1, 2, 2, 2, 3, 1, 3, 2. Show that R is a binary relation on A. Find its domain and range. First we need to prove that R is a binary relation on single set A. Binary relation means the first set and the second set in the Cartesian product is A. Hence this set R must be the subset of Cartesian product of A cross A. So first we write down A cross A. So first element in this set will be connected with each and every element of second set. So 1, 1, 1, 2, 1, 3, and then second element will be taken into consideration. 2, 1, 2, 2, 2, 3, then 3, 1, 3, 2, 3, 3. It is the Cartesian product of A cross A. And then we need to check whether this relation R is the subset of A cross A. 1, 2 is in relation R, here also it presents. 2, 2, 2, 2 also present, and 3, 2 is there in the relation R, which is present in this A cross A also. Hence R is the subset of A cross A. Hence R is a relation on A. And then we need to say what is domain and range. Domain is the set of all first coordinates of this relation R. So domain R is equal to 1, 2, 3, right? And range, we need to write down range of this relation R, which is equal to set of all second coordinates of the elements. Here only one number is present, that is 2. Hence these are domain and range of this set relation R. I hope you understand this concept. Normally in relation our Cartesian product will be A cross B, but here since it is a binary relation on A, the Cartesian product will be found between A and A itself, that is A cross A. Now we move on to next question. Let n be a set of all natural numbers. So we are considering set of all natural numbers, and let R is a set which contains the elements A, B such that A, B belongs to natural number, and 2a plus b should be equal to 10. So a and b is related by this mathematical expression. 2 times of a is added with b means it must give 10, and a and b must belong to natural number only. Show that R is a binary relation on R. Find its domain and range. So R is a binary relation on A means the Cartesian product will be found between A only. So A cross A. So A cross A, first we cannot list the A cross A here because it is a very difficult process, because set A contains set of all natural numbers. There are infinitely many natural numbers are there, so it cannot be listed down. First we need to just check whether the set R elements are subset of natural numbers or not. That is A cross A. That means first element also should be a natural number, second element also should be a natural number. So A comma B, which satisfies this condition, means it can be 1 comma 8, because if you substitute A value as 1 and B value as 8, we get 10. Similarly, A value as 2, B value as 6 means we get 10. Similarly, we can check with these two. So if you observe this set R, relation R, the first elements, that is 1, 2, 3, 4, set of all first elements belongs to natural number, and set of all second elements also belong to natural number. Hence this relation is the subset of natural numbers. Hence this is the relation under this condition. And then we need to find out domain and range. Here domain is set of all first coordinates of the elements, that is 1, 2, 3, 4, and range is set of all second elements, that is 2, 4, 6, 8, and codomain is the second element in the second set in the Cartesian product. Here Cartesian product is found between A cross A. Here A belongs to natural number, B the second set also belongs to natural number. Hence codomain is natural number. I hope you understand this problem. Now we move on to next question. Let R be a relation on the set of all integer Z, defined by relation R is equal to A is a set which contains the elements A comma B such that A comma B belongs to integer and A minus B is a even number. Find its domain and range. So condition is the second element should be subtracted from first element, and the result must be even number, and A and B must be a part of integers. Clearly A minus B can be even when both A and B are odd number, or A and B are even number. If you subtract even number from even number, you will get an even number, and or if you subtract a odd number from an odd number, you will get an even number. Hence the elements of A comma B, elements of R belongs to the Cartesian product of this Z cross Z, and domain is set of all first elements. Set of all first element is the set of all integers, and range means set of all second coordinates of the elements of R, that is also R. So that is also integers. So domain of R is set of all integers, range of R is set of all integers. I hope you understand this problem. Now we move on to final question, that is let R is a set which contains the elements x comma x cube such that x is a prime number and x should be less than 8. Write down the relation R in a roster form. Here we should list out each and every elements of set R. Here x is a prime number and it must be less than 8, means the prime numbers less than 8 are 2, 3, 5, 7. Hence here x should come and x cube will be written. Hence 2, 2 cube, 3, 3 cube, 5, 5 cube, 7, 7 cube are the set of elements of relation R. Here we are just writing 2 cube, 3 cube, 5 cube. I hope you can understand this problem. With this we are completing the concept relation. Thank you students. Thanks for your cooperation.